All right, so our last type of transformation that we're going to work on is called a dilation. So a dilation means it gets bigger, so it enlarges, okay? Or it gets smaller, so we would call that a reduction, okay? And it always does that from its center of dilation. So we're only going to do dilations from the origin. And so what that means is if I have a triangle that's just hanging out right here, okay, at the origin, it's actually getting bigger and moving its points, okay? So just know that your triangle could end up in weird places. For example, here's like a little square. If it got really big, it might not even actually touch the other original square. So don't freak out if you end up in two different places. Let me show you how we do the rules for this. We have what's called a scale factor. We call that K. K is the scale factor. And so if I had a, let's just say a quick little triangle. So if I had a triangle at 2, 3, 1, 1, and 3, 1, and I have a scale factor of 2. What that means is each of these 3 points, I'm going to multiply the x and the y by that scale factor. So the new points on my triangle are going to be 2 times 2, 2 times 3, which is 4, 6. Okay, 1 times 2 is 2, 1 times 2 is 2. 3 times 2 is 6, 1 times 2 is 2. So if I were to sketch this real quick, this is my original picture, 1, 2, 3. This is my first point. 1, 1 is right here. 3, 1 is right here. So this is my original or my pre-image. And my image here is at 4, 1, 2, 2, and this is supposed to be a 6. That's why I messed up. I read this as a 6, but it was 4. I read it as a 1, and it's a 4, 6. Okay, so I had my points of 4, 6. That's right here. 2, 2, which is right here in the middle of the triangle, and 6, 2, which is right here. So here we go. That is my image, my dilated of the pre-image. So that's how you're doing this kind of problem. Let's take a look at what you're going to do in Delta Math, just to make sure that you understand how to do it in, since, you know, last video I kind of messed that whole thing up. So here we go. Let's go to me sharing my screen. I'm not sharing quite the right thing yet. I'm still from rotation. Dilation of a point. Here we go. So one example problem here. What is the image of 9, -7 after a dilation by a scale factor of 4? Okay, so what we're doing is we're multiplying. 9 times 4 is 36. -7 times 4 is -28. So that's too big for me to bother graphing, but you could if you wanted to. So we've multiplied each by 4. Okay, so we could do that again. And I was going to look and see if I had a fraction one. There we go. So if you have a fraction, you're doing the same thing, but you are multiplying by that fraction. So if I had this problem, it said, I'll pull it back up in a second. It said that we have a point of -12, 4. Okay, so -12, 4. And our scale factor, our K, is 1/4. So our new point is -12 times 1/4 and 4 times 1/4. And that equals -12 divided by 4 is -3, 4 times a fourth is 1. So in that case, it got closer to the origin. So if you get a fraction, you know what to do. Just use the fraction, multiply by that fraction. Okay, the other one that we're going to have is dilations on a coordinate plane. So the figure below is dilated by a factor of 1/2, okay? So plot the resulting image. We're gonna click twice to plot a segment. So what we're doing here is we're taking these and figuring out where do they go. So for example, here we have, this is pretty long, but it's gonna actually start at 3 now instead. And this point is at 8, -2. So 8, -2, its dilation would be at 4, 1. So I'm kind of doing that multiplication in my head. Okay, point P is currently at 2, -6. So its new point is going to be at 1, -3. I have to connect that to my last point. Okay, right here we have T, which is at -8, 2. -8 divided by 2 is -4, and we're going to come down to 1. So again, I'm just going to connect that. This one, you know what? I'm going to do this the easy way. It was going up 2 over 2. It's going to do half of that. It's going to go up 1 over 1. And then I'm going to connect it to my last point. Okay, so there's some tricks you can do if you want to, once you have some of it going. But in general, you're just dividing or multiplying. Let me know if you have any questions.